Hello everyone, welcome to this video. In this video, we'll be looking at a question which states that does a homomorphic image tell us anything about the group, or what is the utility of studying homomorphism at the first place, right? So in the previous video, we saw how we can use fundamental theorem of group homomorphism to have a relationship between two groups which are of similar kind. Now, what in general, if we study homomorphism, what information do we get from that, right? Or is it worthy to study homomorphism at the first place? Why are we at all studying it? So the answer to this question is that just like factor groups provide information about the group, do you know that, right? In a similar way, homomorphic images provide us some information about the properties of the group. Now, some student has in mind that we already know about our group, so why is it required to study homomorphism? So the teacher here tell you that in some cases where the group structure is unknown, only the homomorphic images are available to us. In that case, we can have hints about our original group. Now, why is that necessary? Because it is similar to solving an inverse problem where from the homomorphic images, we are performing inverse analysis to reach at our group. So that means initially you do not have your group, but you have some information with you about the group. That information is obtained from this homomorphic images, right? So using that information, you can have hints and you can you can make guess about your initial group which was not known to you and was required in order to solve some real life problem. Now, right, so this is how we use the group. In particular, one such property is obtained by measuring the size of the kernel. How does kernel provide us information? So let's see this thing. If the kernel has only the identity element within it, that means the size of the kernel is just 1, then according to the fundamental theorem of homomorphism, this homomorphic image of the group would be equal to the group divided by the kernel, which is identity in this case. And what is this? This is the group itself. So the group is exactly isomorphic to its homomorphic image. So that means if the kernel has only the identity element within it, then the image of this group G tells us everything about this group G, right? And if the kernel has whole of the group, right, kernel is basically the group itself, right, then the homomorphic image, what would be G, the factor group of G where the kernel is G, it is just the identity. So you see your homomorphic image is just the identity element, right? So that means from this homomorphic image, we get no information about the group. We know nothing about our group G. But what if we have a case in which the size of kernel is lying between 1 and the size of group G? In that case, the homomorphic image reveals some information about our group G while some information is lost, right? So this is how the size of kernel tell you about the nature of the properties which are obtained from the homomorphic image, right? Thus the utility of particular homomorphism lies in its ability to preserve the group properties we want, and while losing some essentials one. If you already know your group and you require some of the properties and some properties are not required, so what you do, using these properties we can construct our homomorphic image in such a way that we have the smaller size group which is less complicated and easier to study, and it answers all the questions about our group G. So basically all the essential properties are preserved and non-essentials ones are eliminated from it, right? So we have shrinked our group in such a way that the information is preserved, the important information is preserved while the unimportant information is lost, correct? So we can also see an analogy between photographs and homomorphic images. How is that so? You know, a photograph of a person cannot tell us what is the exact height of that person, what is the exact weight of that person, or what is the age of that person. However, by looking at the photograph, we are very sure that whether the person is tall or short. We can know whether he is heavy or thin, he or she is heavy or thin, he or she is old or young, or he or she is male or female, correct? This thing we know by looking at a photograph. However, these information is not precisely known to us. So in the same way, homomorphic image give us some information about the group, while other information is not known exactly to us. In a similar manner, you can also have photographs from different angles of a person, right? For example, you can have a front view profile, head to toe profile, rear view profile, close up of that person. For example, in x-rays we have the front section, back section, right? In a similar manner, we have many projections of our body. So from looking at those photographs, you can reveal much information about that person, right? In a similar fashion, by looking at several homomorphic images, you can have many homomorphism defined for a group. So looking at the homomorphic images of different homomorphism, you can have many information about the group itself. Now, one would say that why are we taking photographs from so many angles? Why can't we go for a video of a person would reveal much about it? So instead, I would say you just go to the person and meet the person. You will get to know everything about that person. But that is not possible for groups. If that is possible, that could be performed for a group, the whole story of studying this group theory would be inessential, right? So basically, it means that more homomorphic images you have of a group, the more information you can gain from that. So this is the utility of studying homomorphism for a group. So I hope you understood this question well. That is it for this video. Thank you for watching.